Okay, let's take a look up here. Volunteer to tell me what equations I would write. Dina.
0.1d plus.
Oh, hang on, I'm not plugged in yet.
This was a bad idea.
Okay, here we go. 0.1d
Plus 0.05n equals 1.55.
Okay, and what would the other equation be?
D plus n equals 20.
Okay, so those of you who are confused by coin problems, you write all the equations the same way. Usually I write the one that she wrote second first. The first equation just gives us the number of dimes plus the number of nickels equals however many there are. In this case, I have 20, so the number of dimes plus the number of nickels is 20 coins altogether. The second equation, we use the value of the coins. So dimes are worth 10 cents, so we multiply the number of dimes times 10 cents. We multiply the number of nickels times 5 cents, and that's going to equal the value of the money, which is $1.55. Does that make sense? Anyone still confused by that? Okay. All right, let's go through solving it. Do you want to use substitution or elimination? How about a different volunteer to solve it? Sophia? You could use either, but let's use substitution. What do you want to solve for? N? Okay, so N equals what? 20 minus D. Okay, now we'll put that into the top equation. Plus 0.05 times 20 minus D equals 155. Okay, Sophia, you want to keep going with the solving of it?
Can you distribute 0.05?
Mm-hmm.
And then you get 1
1.
minus 0.05 equals 20.
Okay, now what?
Then you would combine the two.
Okay, so you get you're just taking 1 dime minus, yeah, essentially you're taking 1 dime minus 1 nickel if we have a nickel left. Okay, 0.05 D plus 1 equals 155. Okay, now what? Okay, good. We end up with 0.05 D equals, good. Oops. And so D equals okay, so a different volunteer, if D equals 11, what does N equal? I want a total different volunteer. Colin.
9.
What?
19.
No, 11 plus 19 is not 20.
Oh, I thought you said 1.
No, D equals 11. We have 11 dimes.
Oh.
So how many nickels do we have?
9.
9. There we go. All right, so the number of nickels is 9. Okay, any questions about the coin problem before we go on? CJ.
Is that like do next to 0 minus D? Is that slashing to it or do you?
No, that's just my pen not doing what it's supposed to do. Same thing happened. Whoops. Same thing happened there. Same thing happened here. Boy, I have a lazy pen today, or a lazy hand, I don't know. Okay, now we're going to go over the homework. Okay, so this homework that we're going over is page 390. We already did number 2 on the flip chart, so even though that was part of the assignment, we are not going to go over that. Okay. We are going to start with number 9. Okay, number 9 is a slightly different problem. It didn't fit quite the same cookie cutter mold as all of them. This one talked about someone putting money in 2 accounts, and we had to find out how much was in each account. So I'm going to define some variables here so we're all on the same page. I'm going to say let A equal account A, or the amount of money in account A, and let B equal account B. So I'm going to use A and B rather than X and Y. Okay? You can give me the equations you think might be right for this one. Tina?
No.
No?
I mean, what page was this on?
This is page 390, number 9. Colin?
All of mine, I just used X and Y.
Okay, go
And I
ahead.
have X plus Y equals 1500.
Okay, I'm just going to change that to A plus B equals 1500. Okay, what about the second one?
Then I have 0.05A plus 0.04B equals 1650.
Good. That's exactly correct. Okay, so the first equation is just telling us we know that 1500 got deposited into the account, so the amount in account A plus the amount in account B was $1,500. The second equation, just like the coin problems where we put the value of the coins, we put the interest rates. So account A is earning 5%, account B is earning 4%, and the total interest earned was $69.50. Okay, to solve this, you could use either substitution or elimination. Either would be fine. Anyone want to volunteer and just tell me what the answers are? We're not going to go through the whole process of solving. Sam? 950? Okay, so in our case, A equals 950 and B equals 550. That is correct. Okay, any questions about that? Yes.
Can you go through and solve that?
Yes, I can. Okay, let me just erase. Actually. Okay, what do you want to do, elimination or substitution?
Substitution.
Okay, substitution, I would probably solve the top one for A. So A equals 1500 minus B. Okay, then putting that into the second equation, we have 1500 minus B, bless you, plus 0.04B equals 69.50. Oh, same way I did on my paper. Okay, so this works out to be 75 minus 0.05B plus 0.04B equals 69.50. Now I'm going to do 2 things at once here. I'm going to combine my like terms, so I'll get negative 0.01B. I'm also going to subtract 75 from both sides. When I do, I get negative 5.5. Dividing both sides by negative 0.01 gives me B equals 550. And then I would substitute that in to get A.
Okay.
Okay? Okay, next problem was number 10, the one about the cells. Just so we're on the same page, let's let C equal the number of cells, and let's let H equal the number of hours, because it wants to know when will the cells be at the same amount, and it's telling us a rate, an hourly rate. So we'll let H represent hours. Okay, volunteer for equations on this one. Okay, go ahead, Athena.
Y equals 2000x minus 6000.
Not quite. Not quite. Instead of 2000x, you're saying that they're increasing at a rate of 2000x, but then you would take away 6000.
That's what I said.
Yeah, I know, I'm repeating what you said, but that's not quite the way it happened. We're starting with an amount of cells, and then they're decreasing. So if they're decreasing, the rate itself is negative, so that 2000 is the part that's negative. And the amount of cells that we start with is positive. So instead of 2000H minus 6000, we need to start with 6000 and subtract 2000H.
why does it matter which way you put it?
Because the way you're putting it, you're saying that it's increasing instead of decreasing because you don't have a negative sign here. So you're saying that it's increasing, and then you're going to just take away 6,000 cells.
Okay.
Okay, when it's actually starting with a certain amount, so it's starting with a positive amount and then it's decreasing. So what do you think the other equation would be?
Y equals 2,000 minus 1,000x.
Good. Okay, does anyone want to see this actually solved? Or are we okay to jump to the answer? Okay, let's jump to the answer. What did you guys get as an answer? Sophia? What? For H? Okay, so H equals 4 hours. Then what does C equal? Did you find that? I almost stopped at this one too. It seemed like, oh, we know the hours, we know enough. Zan? Negative 2,000. Here's why it's important to find both variables. Wow, that's really skipping today. Okay, negative 2,000 cells. So this is when the amount of cells will be equal after 4 hours, which that seems to make sense because, yeah, positive amount of time, that's a good thing. However, after 4 hours, look how many cells we're supposed to have. Negative 2,000 cells. Can we have negative 2,000 cells? No. So this one does not have a viable solution. Okay, any questions about that one before we go on? Kat?
I just have a quick question.
Uh-huh.
For this, would you, if it's not a viable solution, would you like us to say that on the paper? real
Yes.
quick? Okay.
Yes. So if you get a solution that's not viable, you should say that. It's most of the time they are viable solutions, but because we had this set that we're not, you're going to get a few that aren't. Rosa?
Can you solve it?
Yes, I can solve it. Okay, so to solve it, let's see. To solve it, I'm going to let both sides equal one another because both are equal to C. So I have 6,000 minus 2,000 H equals 2,000 minus 1,000 H. Okay, I'm going to move all my H's to one side, so I'm going to add 1,000 H to both sides, which gives me negative 1,000 H. Now I'm going to subtract 6,000 from both sides, which gives me negative 4,000. So I'm doing two steps at once here. Okay, dividing both sides by negative 1,000 gives me H equals 4. So that's where we get our 4 hours, which if we stop there, we think that we have a viable solution. But then when we solve to find out the number of cells, we find out we don't. Okay, any other questions about this one? Okay, let's look at 13. 13 was just a coin problem, so we've done a number of coin problems now. So I want new volunteers. Someone who has not volunteered yet. Tell me how to do coin problems. Dan? Good. Boy, my pen keeps doing all kinds of weird extra things today. I think it's me. I think my hand is just sluggish. Okay, I'm going to solve this one using elimination because we've done all the other ones using substitution. I'm going to multiply my top equation by negative, actually, do I want to do that? No, I'm going to use substitution. So P equals 15 minus Q, but you could multiply this by 0.01 negative. Now 0.01 times 15 minus Q plus 0.25Q equals 435. Distributing gives me 0.15 minus 0.01Q plus 0.25Q equals 435. Now again, I'm going to do two steps at once here. I'm going to combine my like terms. So I get 0.24Q. I'm going to subtract 0.15 from both sides, and I get 420. Dividing both sides by 0.24 gives me Q equals 17.5. Anybody see a problem with this already? What's the problem, Sophia? You can't have half a coin. Now, if we were to keep going and we were to then solve for p, we would get, this is an even bigger problem, we get p equals negative 0.25. So not only do we have half a coin, but we're like in the hole 2 coins, I don't know. So this one is not a viable solution. And you probably didn't expect that with a coin problem. You probably expected to get the right answer. I know I did. I got that. I'm like, wait, did I do something wrong? And then I realized, oh, part B is asking if it's viable, so that's why. Okay, one more that we're going to do together is number 22. Questions about this before I? Okay, number 22. Let's see, 22 was about, oh, the perfume. Okay, any volunteers for equations on number 22? Adam?
X plus 5 is 3.
Good. So he did x and y, which is fine. X plus y equals 3. What would the other one be?
8x plus 35 equals 63.
Plus 35y equals 63. Good. So the first equation is just a simple equation saying the number of ounces of x plus the number of ounces of y has to equal 3 because we have 3 ounces total. The second equation uses the value x costs $15 per ounce, so we multiply 15 times the number of ounces plus 35 times the number of ounces equals the total cost, which they gave us as 63. This one I'm going to use elimination. So I'm going to multiply the top equation by negative 15. I get negative 15x minus 15y equals negative 45. And that gives me 20b equals 18, and b equals 0.9. Substituting back in, we get that a equals 2.1 ounces. Okay, any questions about this one? Okay, I'm going to give you a worksheet with more problems like this because the best way to get good at doing these is just to do lots of them. These are super easy for me to do, but only because I have done hundreds of them. So when I was your age and I was doing this for the first time, I thought they were really hard. Yeah, I'm going to go over a couple with you just to get you started, and then yes, you can look at partners. So I'm going to keep recording so that people who aren't here can see a little bit about how to do this. Is this the hunger banquet where some of them get to eat and some of them don't?
Yeah.
Some of them get to eat.
That thing, that is.
So some of them are missing out.
I hate that.
I was too.
Yeah, I think it was because you were.
Oh, yeah.
No, I was saying, I think it's just.
Okay. There are, guys, come here, There are 2 problems I just want to preview with you just because they're different than some of the problems we've had so far. The first is number 1. Just looks a little bit different. It says, find the value of 2 numbers if their sum is 12 and their difference is 4. Okay, so what would I define as my variables? Colin? X and Y, and what do X and Y stand for? The 2 numbers, okay? So we're going to let X, that's a weird L, let X equal the first number, and let Y equal the second number. Okay, now it says their sum is 12 and their difference is 4. So what 2 equations could I write? Colin, go ahead, take this.
X plus y equals 4.
Uh-huh.
And then x minus y.
Good. That's all there is to it. Okay, so if you want to copy that down so you have the problem, we're not going to solve it. Just remember, if you look at the sideboard, I wrote a little reminder up there for you guys that x plus x does equal 2x and not x. So just remember that when you solve this problem. This is really easy to do by elimination, but it won't be easy if you add the x's wrong. Okay, the other one that I want you to take a look at is number 4. Number 4 says, the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. Okay, so let's define some variables. What 2 things are we looking to find? Sam?
Child's ticket and senior citizen.
Okay, what variables do you want to use?
X equals child's ticket.
Okay, so X will be the child's ticket, or specifically the cost of the child's ticket, and Y will be the adult ticket. Okay, what equations could we write for this? Sophia?
X plus 3y equals
My second. Yep, that's right. I was looking at, I have mine written differently. I have it written the other way. My X stands for the price of the senior, my Y stands for the price of the child. So say that again.
3y plus x equals 38.
Okay, good. 3y plus x equals 38. So we write an equation for day 1. Day 1, they sold 3 adult tickets or senior tickets plus 1 child ticket, and they earned $38 altogether. Okay, what would the second equation be? Go ahead.
3y plus 2x equals
Good. 3y plus 2x equals 52. Okay, and then you would solve those. Elimination would be pretty easy for that system as well. Just one other comment about these. Number 5 is kind of a tricky question. If you get stumped on number 5, feel free to leave that one blank and come back to it. Don't panic if you can't get it. 5 I'm not too worried about. We will talk about that, but it's a little bit different. Okay, so what I want you to do is work on this. You can work with partners. I would encourage you to get them all set up first, because you can solve them on your own if need be, but you really kind of might need the collaboration with somebody else to get them set up right.